At every single moment of your being, you are not just simply being. You are moving through an intricate web that stretches not just over everything we know, but past. Dimensions are a very difficult thing to explain and imagine because they're not tangible, they're not actually there. But even so, their existence is what explains our existence. I know when I first started thinking about dimensions, all that was coming to mind was the measurement units in math. And while length, width, and height are supposedly pretty straightforward, dimensions are so much more than that. The main question that came into my head was, what actually is a dimension? We know they're intangible, so how could we know they're actually there? Well, gravity is intangible, but we know it's there. Could dimensions exist in the same sense that gravity exists? In a way, they do. However, they're more so a boundary than they are a force. By definition, dimensions are the different facets of what we perceive to be reality. They are essentially the planes of our existence. All of the dimensions are constantly surrounding us, but so far we can only prove the existence of 4 of them and can only easily perceive 3. The 3 most known dimensions are length, width, and height. The first dimension, length, you can understand as the x-axis of a graph. It's a line moving in only one direction. The second can be understood when you add a y-axis to the graph. You now must give an xy coordinate to plot a point. The third dimension comes into play when you add depth. There would have to be a third axis, and a figure in the third dimension would have an xyz coordinate, length, width, and height. A horizontal line exists in one dimension because it only has length. A square is 2-dimensional because it has length and width. Add depth and we get a cube, or a 3-dimensional shape. While these 3 are the easiest to visualize, there is a fourth that is just as real even though it's not quite as tangible. That dimension is time. Believe it or not, just like we can move through and manipulate the first 3 dimensions, we also move through time, however, with much less control. The dimension of time is not one that is easy or even possible to visualize. The 4th dimension is a line that can join the universe as it was 1 minute ago to the universe as it is right now. To understand time best, you have to think of the 4 dimensions as one: space-time. Space-time is like a perfectly thin trampoline fabric. The only thing that can affect space-time is gravity. It stretches and curves space-time. The more intense the gravity, the bigger the stretch. Anything that has mass is going to alter space-time. Just like how if you were to put a bowling ball on an actual trampoline, the fabric would stretch to accommodate it. Theoretically, if a massless object is rolled straight across this trampoline, it will go straight and reach the other side. However, if there is something that has mass on the trampoline, the massless object will move on a curved path. This is what we know as gravity. In this video, the massless object swirled inwards and crashed into the object with mass. However, in reality, the circle this massless object ends up on, otherwise known as an orbit, gives it constant acceleration that allows it to maintain an equilibrium with the curvature of space-time caused by the mass. The theory that our dimensions could be stretched was the work of who else but Albert Einstein. Before Einstein, everyone thought length, width, height, and time were fixed, but using his theory of relativity, he figured out that they can be stretched. This theory was solely mathematical, but a few years later, an English astronomer by the name of Arthur Stanley Eddington observed an eclipse and viewed a star that shouldn't have been seen because it was behind the sun from Earth's perspective. However, due to the mass of the sun creating a strong gravitational pull, its light was bent and could be viewed from Earth. That proves the curvature of the space-time and any other possible dimensions by gravity from any mass in the universe. Any other possible dimensions? What is that supposed to mean? Well, now we know that there are 4 dimensions, but what would you think if I told you that according to string theorists, there are at least 10 dimensions of space, most of which are impossible for humans to perceive? Add time and that's 11 dimensions. The proof for knowing that these additional dimensions exist is that the 2 main theories describing how the universe works, general relativity and quantum mechanics, don't work in this 4-dimensional universe of ours. They do, however, work in a universe that has 11 dimensions, 10 in spatial and 1 in time. All of these other dimensions are predicted to be much too small for us to perceive. To understand how such important things could have completely escaped our notice. Imagine that instead of three-dimensional beings living in a three-dimensional world, we are two-dimensional living in a two-dimensional world. In this 2D world, our abilities to move are limited to left, right, up, and down, as opposed to the additional forward and backwards we could move in the 3D world we actually live in. If at some point our world was to thicken, we would now be able to move forwards and backwards too. However, to beings where a 2D world is the only thing they've known, the additional third dimension would be much too small to perceive. String theorists have in mind something like 10 to the negative 35 meters. It is expected that these minuscule dimensions are likely curled up. With some fancy folding, a 2D object can be curled into a torus, which is like a donut. When you add the extra hypothesized dimensions, though, it can be curled up into many different forms. The possibility of comprehending and being able to manipulate the fourth dimension would mean that we would need to be able to identify and experience the fifth, just like how us, living in the fourth dimension, can manipulate the third. If you think of the dimensions as a hierarchy that looks like this, each one above the next is the one you have to travel through to get from one spot to another on the one below it without ever having to be in between. Each higher dimension treats the one below it as a single point. In fact, when following string theory, infinity becomes a single point in the seventh dimension. If you'd like more information on string theory and its relation to dimensions, check out the Perimeter Institute's website under the Quantum Fields and Strings tab. Now on to the fun stuff and some theories about our universe in relation to dimensions. If the dimensions were to curve so much that they ripped, which is essentially what a black hole is, the black hole becomes a point of 0 dimensions in our universe. It does not have length, width, or height. Even time is altered at the point of a black hole. This point of 0 dimensions would be considered nothing in our universe, but could be considered anything in another universe. A black hole in our universe takes everything into it, but wherever it goes, it could be pushing things out. As far as we know, information can't just disappear and go nowhere. It has to go somewhere. If you can imagine what the other side of that black hole might look like, it would be a blinding flash of light and mass. This is the result of the side of the black hole being so dense that nothing with any amount of acceleration can escape, even light. That means that to escape the pull of a black hole, you would have to be going faster than the speed of light, which as far as we know to this day is impossible. On the other side, this blinding flash of mass and light would create rapid and continual expansion, as long as the black hole continues to pull in mass from the plane it exists in. Sound familiar? What blinding flash of light and mass with rapid expansion is most understood by us? The Big Bang. So, could our universe be the other side of a black hole? Well, maybe. If you consider the known volume of our universe and compare it to its mass, our universe has a density very similar to that of a black hole. A black hole has an infinite density, which is much like our universe because the mass is growing along with the volume expansion. And further, the phenomena of dark energy could be the result of matter from another dimension falling into the black hole that is us. Dark energy is everywhere, all the time. Just like how a black hole, being a singularity, anything falling into it from another dimension would appear everywhere, all the time, and ours. Another cool idea is what might happen to our perception of dimensions if we were able to get past the speed of light. As something that has mass speeds up, it gets heavier and heavier, making it impossible for it to get past the speed of light. But if there was something that had negative mass, not antimatter, but something below 0 mass, it could theoretically get past the speed of light. You see, as you get closer to the speed of light, time actually slows down. At the speed of light, time stops. And in theory, if you were to go faster than the speed of light, time would potentially go backwards. If this were possible, we would essentially be manipulating the fourth dimension, time. So theoretically, getting past the speed of light may allow you to perceive the fifth dimension. Without dimensions, we couldn't exist. Our presence in the universe would be a jumbled mix with no end or beginning, shape or size, and no sense of direction. The concept of dimensions past the well-known 4 is still one of the most mysterious and intriguing topics in physics, and it could hold many secrets to how us, the world, and the universe works. So, how can we better understand them? To we focus in or focus out? Do we look within ourselves or to the far reaches of the universe? Research into this field is so important. It could explain some of our greatest mysteries. We've got to get going on this research so that we can build upon the discoveries to better explain our existence. Our time is limited. Or is it?